Okay, next part of IR topic is how to interpret the IR spectra. Okay, interpret IR spectra means when you are given a spectra or you are not given a spectra. Okay, so the exercise that we did last week is when you are not given any spectra. But at the end of this topic, I will provide a series of questions and how to answer the question so that you understand what I mean by that. Okay, so before we look further on this, you need to understand all classes of compound, what are the bond present in the molecule, and then what is the frequency for each bonds. Okay, so we go first on the hydrocarbons. So for hydrocarbon, we have alkene, alkene and alkyne, and also aromatic compounds. So how to differentiate these four? First, when we talk about alkene, there must be presence of CH bonds. Yeah, CH bond. So there are three types of CH bond, which is CHsP3, CHsP2, and CHsP. CHsP2, when you have a double bond and aromatic in the molecule, you must see the CHsP2. For CHsP is when you have the alkyne, but when you have a symmetrical alkyne, you can see the CH bond. Not symmetrical. What we call that word? Terminal and internal. Okay, terminal and internal. So what I mean by this, when you have the alkyne, you can see this CHsP. But when you have this alkyne, there is no CHsP. Okay, so depending on the structure of the molecule, so that from there you know what are the bonds present. Okay, so back to CH, we have CHsP3. So this is the frequency. So how to spot that you have CHsP3? Look at the spectrum, anything below 3000. Okay, but you have other bonds as well, but I will explain later when we reach that class of compound. But for in this case, when you have how to differentiate if you have CHsP or sp3 or you have CHsP2. Okay, anything below 3000, possibility to have CHsP3. Anything above 3000, possibility to have CHsP2. But at the same time, when you have CHsP2, you must have C double bond C. This is like when you have this, you must have this. Okay, so for C double bond C, you can check the frequency from the correlation chart. So this is approximate. Okay, approximate the peak of C double bond C present around this frequency. Okay, there are three types of C double bond C. The isolated means you only have one double bond, and you can have two double bond in the molecule, and you can have three double bond as well in the molecule. Okay, it's just that C double bond C for alkene and C double bond C for aromatic, they appear at different frequency. Okay, so check back your correlation chart. Yeah, C double bond C is around 1645 and C double bond C aromatic is around 1614 something. Okay, so for C double bond C aromatic, you must write two value. One is 16 something and 14 something N. Yeah, the word is N. But for C double bond C alkene, It's only one peak and it's around 1645. Okay, so this is the list. When you have alkane, you must see CHsP3. Again, just omit the bending vibration. And for for alkene, you must see CHsP2, which is above 3000. Just check and think about 3000. And when you have CHsP2, you must see C double bond C around this region. Okay, so that is the two things that you need to look when you have an alkenes. And then for alkyne, as I said earlier, you must see C triple bond C if the alkene is unsymmetrical. So what is it mean by unsymmetrical? Let's say you have this structure. Remember, IR active and IR inactive. Even though you have C triple bond C in your structure, but no way that you can see C triple bond C peak in the spectrum. What is the reason? Remember, the dipole moment is equal to 0. If the dipole, the change of dipole is equal to 0, this bond is IR inactive, so you cannot see the peak in the spectrum. So how to do this? How to know this? Normally we will give you molecular formula. So no way that we give you the spectrum, but we expect you to identify that this compound is symmetrical alkyne. Normally we will give you molecular formula, so from there you can spot that this alkyne is symmetrical alkyne. Okay, for C triple bond C, which bonded to again to this bonded to H, so you can see the CHsP. But if the alkyne is symmetrical alkyne like this, okay, you cannot see the CHsP, but that compound is alkyne. There will be additional information that direct you to conclude that the molecule is alkyne but symmetrical. Okay, so we will have a question on alkyne, so to explain more on this concept. Okay, for aromatic compounds, you must see the CHsP2. And when you look at correlation chart, the CHsP2 for alkyne and for aromatic is quite different. Okay, the frequency is not the same. Even though both are CHsP2, but CHsP2 for alkene and CHsP2 for aromatic, they appear at different frequency. OOP means out of plane, so you need to ignore that is the bending vibration. And then the next thing that you need to list down is C double bond C for the aromatic, and N. Remember, the word N here means when you list down C double bond C aromatic, the frequency must be 1600 something and 14 something. The word must be N. So these two differentiate between C double bond C alkene and C double bond C aromatic. So for example, actually I have a book, I have a handout, more than 30 pages. Normally I give to the student as a handout, but since everything is online now, I don't have time to scan all pages because the copy is in hard copy. But the list that I give you on the spectrum is actually a compilation of all this, so just refer to the notes that I give to you. Okay, so now we move to the next class of compound, which is alcohols and phenols. So for alcohols and phenol, what you can see in the spectrum, or what you can list down the bonds present in alcohols and phenol, the most important is the OH. Okay, the OH peak is very broad, so no way that you can miss the OH peak Okay, so other than that, you must see the CO. CO is a bit confusing, because the range of CO is quite far, 1200 to 1000, but you can choose any peak between this region, but it must fit, it must it must fit to the class or compound when you have the alcohol or phenols. Okay, so let's say you have this structure, 3-pentanol. Okay, so the basic skeleton of the molecule, you must see the CHSP3. Oops. Okay, you must see the CHSP3. CHSP3. At the same time, you see the OH and you see the CO. Okay, so that is for alcohol. For ether, okay, you only see the CO. Means the word here absent of CO and OH means ether is the simplest spectrum that you can spot. Okay, when you see only CO, but normally ether will be the last choice after all the possibilities is not fit. Yeah. Okay. Next one is amines. So there are 3 types of amines: primary, secondary, and tertiary. Okay, so when you have amines, when you see 2 spike or 2 bands, okay, when you look at the spectrum, you see something like this. You call it a spike, and then you see something like this in the region of 3500 into 3300. Means when you see 2 spike, that is primary amines. When you see only 1 spike, it's a secondary amines. So how to know if you have a tertiary amines? Because there is no spike between 3500 to 3300. Normally we will give you a molecular formula. So let's say the molecular formula consists the N atom, but from your spectrum you don't see any spike, so means your compound is tertiary amines. Okay, you must see the NH and CN. Okay, just ignore the bending vibration. Okay, next one, the nitrile. Okay, so for the nitrile, C triple bonds N, you can see very sharp absorption around 2250, and then the rest is maybe the SP3, depending on the CHSP3, depending on the structure of the molecule. Okay, next one is on the aryl and alkene and aryl halide. This is not very important. Okay, and the last one for this part, I think that's all for this. Okay, so I'll continue with the carbonyl compound, which is more complicated from the non-carbonyl class of compound.
انضم معنا الآن واشترك بالقناة ليصلك كل جديد. YSAG، معا نحو مستقبل مشرق.